So uh, in geoinformatics, right? So what in the geoinformatics there is three distinct parts. One is remote sensing, second is image processing, and the lastly it is GIS or Geographical Information System. So what happens is in case of remote sensing, through a camera situated far away from the geographical feature, suppose let us say for example a hill. If I suspend a camera above this hill and take picture of the hill, then this picture will be somehow you can say somewhat like this, because the camera is suspended just top of the hill. So in this case, what will happen? This is the your remotely sensed image. So this is our camera placed here, and if I take a picture, you can note that I am taking a picture without touching this image, without touching this feature. I am not touching this hill, but still I am taking the picture of it. So this is known as remote sensing, because the camera which is taking the picture of the hill is remotely placed. That is why the image captured through this system is known as remotely sensed images, or as a whole it is a remote sensing. So that is why it is written by definition, remote sensing is a method for getting information about different objects on the planet without any physical contacts with it, right? So this is what is remote sensing is. It generates image, right? After it generates image, the image processing state, what it does is it tries to extract information by processing this image. This image actually stores information in terms of brightness. That means the sun, if there is a sun and the sun have a reflection from the hill surface, and that reflection was captured by this remotely placed camera, and in how it has captured the information of this hill. He has captured What he has captured is actually the reflectance of the sun ray from the surface of the hill, which we can say as brightness or sometimes as reflectance. Now, if there is a pond situated just beside this hill, you will see that in the image, what will happen is this section will look darker compared to this section, as the distance from this to this camera is far lesser compared to the distance of this to this, from the wetland to the camera placed remotely. So when sun ray is reflecting from the wetland, it is traversing more distance compared to the sun ray reflected from the hills. As a result, the energy reflected from this area is much more compared to the energy reflected from this area. So that is why this hill will be brighter in the image compared to this wetland, right? Because much more energy has been reflected in case of hill compared to that of the wetlands because of the distance. So, with the help of this information of reflectance through image processing algorithms and the image, we can retrieve or we can extract a lot of information, geographical information about this area. Right? So this is what is known as image processing step. Now that the information has been retrieved from that image, now we can create a geographical information system such that these information can be retrieved by a user through the geographical information system. Basically, geographical information system acts as a georeference database which stores the geographical information of the image being digitized. Suppose we can digitize this hill as polygon and this wetland also as a polygon, and then create two different attribute tables in which we can store relevant information about the hill as well as the wetland. That was retrieved from at the image processing step. Because this image processing step can give what is the height of this mountain, what is the depth of this wetland, etc. So basically, these three steps, remote sensing, then image processing, then GIS, constitute geoinformatics or a geographically referenced informatics or information system that will provide you with relevant information regarding some geographical features of a specific area. Now, let us say, so you can see that these are the different cameras, that means the satellites used for capturing images from the Earth's surface. And these satellites roam either through the geostationary object, a geostationary orbit, or through the polar orbit. So geostationary orbit is that orbit which circumference the through the equatorial region of the Earth. This is the equatorial region. The geostationary satellites roam just above the equator of the Earth. And if these are the polar region of Earth, the polar satellites roam around just around above the two poles of the Earth. So this is North Pole, this is South Pole, and the satellites move in this manner. So there are two types of remote sensing satellites. One is geostationary satellites, another is polar satellites. So this is a very good definition of remote sensing by the Dr. Nicholas Short. So remote sensing is a technology for sampling electromagnetic radiation, or you can see this as reflectance of the electromagnetic radiation, which is sunlight, and to acquire and read the non-immediate geospatial data from which to pull in for more or less features and objects on this Earth's land, surface, seas, and air. So basically, retrieving the information regarding these land surfaces, sea, wetlands, the information, the geospatial information about these geographical features, which are acquired by recording the electromagnetic radiation or reflectance emitted from a from these features after the sunlight is reflected from them. This entire process is known as remote sensing. That means if this is sun and if this is the land and if this is the wetland, so these sunlights are reflected by this, right? So if I capture this image, this reflected sunlight, and record this in the reel, so that will become image of this hill, of this hill and wetlands, etc. But the process is known as remote sensing, because here remotely placed cameras are placed and is sensing the sunlight reflected from the different geographical features available in the surface of the earth. So that is why this is what is known as remote sensing. So what are the advantage of remote sensing? So it's a view of a large region, right? If you just use your camera from the land, suppose this is the hill and you are standing here and using a camera from your hand, you can just capture this side of the hill, and that also this region, the region nearer to you, will be clear, but the region which are far away from you will be fuzzy because of the distance of the region from your camera, right? But if I place a camera here, a remote location above the hill, then this entire hill can be captured through this camera. So this is a big advantage, and you can retrieve the information in digital manner, and all this information will be georeferenced. And these remote sensors can operate automatically without any help of human being. So it can collect the information. It can capture digital images of the land surface continuously, every season, every day, every time, right? Now this is a brief schematics of the remote sensing. This is actually the remote sensors. So the sunlights are being reflected from land surface or earth crust, and it is being transferred to the satellites, and then satellites is capturing this and sending back to the base station where it is being recorded. Sometimes satellites also record the images, and there are two types of capturing sensors. One can capture only one band, that means brightness, and those can generate only monochromatic or black and white images. And the other type of sensor, more advanced versions, can capture three band of the images, where one band stores the brightness of a specific bandwidth or wavelength of sunlight. Another band stores another specific wavelength of sunlight, and another band consists of another specific wavelength of sunlight. That means when the monochromatic sensor in one pixel will store the brightness or reflectance of a single wavelength of the sunlight. But however, this panchromatic or multichromatic sensors can record three different bandwidths, or the three different, or can record sunlights in three different wavelengths. So the resolution of this type of monochromatic images is lesser compared to this type of panchromatic or multichromatic images. But it will depend upon the type of sensor. Now this you can see there are Landsat sensor. This is just the plane, and camera is fixed in this part of the plane, which continuously captures images, and they can generate this type of true color images. These are Landsat images. Landsat means satellites that is storing land use and land cover informations. So these are the Landsat images. Now this is the Econos satellite generating Econos images. This is the Quick Bird, and this is the Aster. So different satellites store capture images in different manner. Some capture images in monochromatic manner in single wavelength, and some capture images in triple wavelength or sometimes 7 different wavelengths. And more different the wavelengths it stored, more complex and more heavier it becomes, because every information is required to be stored in magnetic tapes. So if you store just the single wavelength of the reflected sunlight, then the storage space required for that information will be much lesser compared to that when you try to store 3 different wavelengths of the images being captured, right? So because the quantity of information is much more in this multiple wavelength storage compared to that of single wavelength storage, right? So so this is actually the satellites, and this is the image it has captured, right? So these are freely available, and but uh, but the coarser resolution images are freely available, not the finer resolution images. Now, so these have already been discussed many times. Through the satellite image, you can retrieve information on land cover, land use, habitats, landscapes, different infrastructure. As satellite can capture images continuously, so multiple images can be captured in different time series, and you can compare those images to see the change. So suppose an image is being captured in the 1970, and if you again capture that image in 2000, then these 2 images can be captured and the difference can be noted down, so that we can analyze what are the impact of change in the climate, because the climate of 1970 is not as same as the climate of 2000, and also the level of urbanization. This can also be noted very clearly by comparing the 2 images captured for the same place, one in 1970, another one is in 2000. So this can also be detected how much urbanization has taken place, because the level of urbanization can be measured or can be estimated by seeing the change in land use of area. If you see that a forest land has been converted to agricultural land, then you can estimate that there is some level of urbanization. Because to feed the excess population or the additional population, you need food. And to produce food, you need agricultural food. So you need to convert forest land to agricultural land, or agricultural land to settlements. So to provide the accommodation to the excess population. So this way, by just observing the conversion of land use, you can estimate whether there is any urbanization taking place in those areas. So if you see in the 1970 image, this area being captured has a forest cover of 70%. Now if you see in the image of the same area but captured in year 2000, and you see that there is only 50% forest cover left, then you can decide, or you can analyze that there is a reduction of 20%. So why this reduction has taken place? To provide food and shelter to the excess population that has come into that place due to urbanization. So this is the way we, through the remotely sensed images of two different decades, we can estimate the level of urbanization. So that is, I am just now talking about this urbanization. So you can use the images for urban planning, road network and transportation planning, city expansion, city boundaries by time, wetland delineation, etc. Yes, in case of agriculture also you can use remotely sensed images in soil sensing, classification of farms, farm condition assessment, agriculture estimation, what type of crop can be cultivated there. Then mapping farm and agricultural land characteristic. This mapping of land management practices, compliance monitoring, all these things you can estimate through the remotely sensed images. So this was what I was just talking about. You see the images of the same area, this same area captured in 1973, 1976, and 1986. Look, it is deep forest in case of 1973, but however the forest cover is diminishing in 1976, and in 1986 it has completely diminished in these areas where settlements has been created. In the 1976 image you see some farmland has been created, which had been indicated by these barren patches among the forest cover. However, in 1986 images, along with these barren lands, or I think the forest land converted into agricultural land, this settlement area can also be observed. So this indicates that yes, there is some urbanization that is being taking place on this area. As due to this only, to provide them food, they are converting forest land to agriculture. And to provide them shelter, they have converted agricultural land to settlement. So this is the satellite image of deforestation. This is aerial image actually. And these I have already said, land use and land cover. Land use means how the land is being used. And land cover means what is the forest cover on the land. Right? Mainly the vegetative cover, vegetation cover of a land. That is land cover. So these images can be used for mapping. This has also been explained in the initial period. We can create DEMs, digital evaluation digital elevation maps (DEM) with the help of the image being captured by remotely sensed camera. And if we just process the brightness of this image, then you can create DAMs, because higher the area, higher is the reflectance. Because higher area is more nearer to the camera which is placed remotely. So hills are nearer to the camera compared to the land. And land are nearer to the camera compared to the wetlands. So using this information, the reflectance information, we can create DEMs or digital elevation maps. And many other geographical maps can be created with the help of remotely sensed images. And not only the remotely sensed images, after processing those images only, we can create these maps which can be used for retrieving geographical informations. So this part I have already discussed. This is the geostationary orbit. This orbit is situated just above the equator, and it is situated at a distance of 36,000 kilometers, so, or 22,300 miles from equator. Okay? So this is known as geostationary orbit, and the satellites which orbits the Earth through this geostationary orbit is known as geostationary satellites. Same is there when the satellites roam around the polar region. So these are known as polar orbiting satellites, because the satellites are following this path to encircle Earth. Now this is very important. You have to use various image processing software to process the captured image by the remote sensors, remotely based sensors. Some of the image processing software is Dash Energy, NV, Illuis, ArcGIS also have some little bit of image processing ability. But the best one according to me is Geomatica softwares, which are very specially made for image processing. One free version is also available in the net, is Geomatica Free. This software can easily be used for processing images. For processing images. Which images? The images that has been captured with the help of remotely placed cameras. So these are some reference. So this is overall a brief introduction to remote sensing and how this remotely sensed cameras, the remotely sensed images can be processed by different image processing software to retrieve relevant information about that area. Now there are hundreds of satellites and they have their own set of images, and all those images are available. Some are available free, but some will charge for providing you the images captured by their satellites. But above all, any remotely sensed image can be processed to retrieve very important geographical features And not only geographical features, it will also help you to detect changes in that area when you compare the images captured at the different time of at different time. That means you may capture an image in 1970 and compare it with the captured of image of 1980 of the same location. And then you try to compare the forest land cover and land use to identify the change. Right? So, but with this, I conclude